Hi guys, welcome back. Have you ever wondered what would integral of linear be? 1 over s? No, 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 no. You are very wrong. It is only the derivative of ln s that gives 1 over s. Why the integral of 1 over s is ln x plus c? Because the first process of integration is differentiation. I explained this in my previous videos. If you've not watched it, then kindly refer to those videos so you will get them on my calculus in 5 minutes playlist. Now, how do we now integrate ln x ds? You can see it is not part of our standard integral. So likewise, the two principles I gave you in the previous video could not be used to solve this too. It is very simple to solve. Okay, look up. Remember that if I have ln x, I consider ln x is same thing as 1 multiplied by ln x. Is that not so? So because 1 is identity element under multiplication. What is identity element? Identity element under a particular operator is such element in which when you multiply it by an element, you are going to get that element back. You understand? Take for example, if I have 2 and I operate it with this element, which is my identity element, so then I'm going to get 2. If I have this kind of equation satisfied such that my E is what is unique in this kind of operator, then I say, so E is an identity element under this operator. So we know that our ln x is the same thing as 1 multiplied by ln x. Yeah. Also recall that I can also write this one as x raised by 0 multiplied by ln x. Is that not so? Since x raised by 0, any number raised by 0 with an exception of 0 is 1. Even if you yourself, if you are opportune to be raised to power 0, you are going to be 1. You can check that out. Now, if I now substitute this back into my integrand, then I'm going to have x raised by 0 ln x divided by x. So you will see now that we have a single integrand before, so then we have two functions now. So whereby the relationship between them is product. And don't forget, I told you if you have integral in terms of products, first thing you must do is to check whether if you differentiate the first one, let's say for example, if I differentiate x raised by 0, whether I'm going to get what is directly immediately after it. What is immediately after it? So you can see that derivative of x raised by 0 will not give me ln x. Likewise, derivative of ln s is not going to give me x raised by 0. Then what are you now going to do? Then you are going to resort to what we know as integration by parts. Integration by parts. I explained how the formula was derived in my previous video. Remember, for integration by parts, that is when you have integral of this form, u dv dx, then you are going to use this formula uv minus integral v du. And don't forget, if you take your u, you are going to take one of the functions you were given as u, then you are going to take the other as dv. Recall that I said the one you take for u, you are going to differentiate to get du. So then the other you take for dv, you are going to integrate to get v. Then immediately after you've done that, then you are going to substitute that into your formula. Okay, now let us check it out here. Oh, now don't forget before I proceed that I gave you some priority order you have to follow when you want to take, one of the function as your u. So the priority order is to check whether you have ln x. So that is your logarithmic function. If it is not there, you check for s raised by something, then you check for e raised by x. So if you check my question very well, let me rewrite it here. I have s raised by 0 ln x dx. Remember that is the same thing as ln x, right? Which is what we are trying to find. Anyway, so from am here, and based on the priority order I gave before, as it was stated in the book of K-Strut, so then we know that my u here is going to be ln x. Definitely the other function is going to be dv, which is s raised by 0. Remember what I said here, the one you take for your u, you are going to differentiate it. You have your du dx. Derivative of ln x will give you 1 over x. Then you can say that your du is going to be 1 over x dx. Likewise, your dv, remember I said the function you take for your dv, you are going to integrate it to get v. Then you integrate it function. If you integrate, remember if you have s raised by n, then integral of s raised by n is what? Xn plus 1 divided by n plus 1. Then this is going to be what? S raised by 0 plus 1 divided by 0 plus 1, which is equal to x. So immediately you are done with this, then you now substitute this into your formula. Remember I said immediately you introduce the formula, that is you take one function as u and you take the other as dv, then you are going to have uv minus integral v du. So don't forget our u here is ln x, my v is equal to x minus integral, what is my v? X, and du is 1 over x dx. What is ln x multiplied by x? Don't say ln x square, because it's a function that stands on its own. I've advised that you should bring, something of this nature. When you have uh, an expression in terms of x, you have to bring it before the logarithmic function. Then you have first ln x minus this guy, we cancel this, then I have integral 1 dx. Recall from the standard integral I gave you that if you have integral 1, then integral of 1 is going to give me what? That's going to give me x. How do we obtain that? That is what you are going to differentiate. What are you going to differentiate to give you 1? You know it is x I'm going to differentiate to give me 1. Definitely integral of 1 will give me x. You understand now? Since we finished with our integration, then you put c. So therefore, we can conclude that integral of ln x dx is equal to ln x minus x plus c. Very simple. Yeah. If you enjoyed this video, please don't forget to like, subscribe, and inform your friend to do so. Thank you.